Introduction. Terraform is a powerful tool that revolutionizes the way infrastructure is managed. In this exploration, we uncover the significance of Terraform in the world of cloud computing, its capability to automate infrastructure provisioning, and its role in enabling infrastructure as code. The need for infrastructure automation. In today's fast-paced digital landscape, organizations demand a flexible and scalable infrastructure to support their applications. Manual infrastructure management is time-consuming and error-prone, leading to inefficiencies and operational challenges. Terraform addresses these issues by simplifying and automating the deployment process. Understanding infrastructure as code. Infrastructure as code, IAC, is a paradigm shift that treats infrastructure configuration as code. With IAC, infrastructure becomes versionable, testable, and manageable through code. Terraform, as an IAC tool, allows infrastructure to be defined, provisioned, and managed programmatically, ensuring consistency and reproducibility. The Terraform workflow. Using a declarative language, Terraform allows engineers to define infrastructure resources in a configuration file. These resources can range from virtual machines to networking components, storage, and security groups. Terraform then uses this configuration to create an execution plan, which outlines the changes required to reach the desired infrastructure state. Finally, Terraform applies the plan, provisioning or modifying resources as necessary. Provisioning with provider plugins. Terraform integrates with various cloud providers, such as AWS, Azure, and Google Cloud, through provider plugins. These plugins enable Terraform to interact with the respective provider's APIs, allowing for seamless resource provisioning. This flexibility allows organizations to adopt a multi-cloud or hybrid cloud strategy, leveraging the best of multiple cloud platforms. Infrastructure as code benefits. One of the key benefits of Terraform and infrastructure as code is the ability to version and track changes made to the infrastructure. By storing the configuration files in a version control system like Git, teams can collaborate effectively, review changes, and easily roll back to previous configurations if needed. Infrastructure becomes auditable and reproducible, streamlining troubleshooting and enhancing security practices. Scaling and modularization. As infrastructure requirements evolve, scaling becomes essential. Terraform's modular approach allows the infrastructure configuration to be organized into reusable modules. Modules can represent a specific component, such as a web server or a database, and can be shared across different projects. This modularization ensures consistency, reduces duplication of code, and simplifies maintenance. Testing and continuous integration. Just like traditional software development, infrastructure as code can benefit from automated testing and integration. Tools such as Terratest and Kitchen Terraform enable engineers to write tests that validate the correctness of Terraform configurations and integration with other components. Continuous integration C pipelines can be set up to automatically test infrastructure changes as part of the development process. Managing state and collaboration. Terraform maintains a state file that serves as a record of the current infrastructure configuration. This state file, stored locally or remotely, ensures Terraform's idempotent behavior and enables collaboration among team members. For collaborative projects, remote state storage, such as Terraform Cloud or AWS S3, provides robust concurrency control and allows teams to work simultaneously on infrastructure changes. Monitoring and continuous improvement. Monitoring the performance and health of infrastructure is critical for maintaining availability and optimal resource allocation. Terraform can integrate with monitoring and observability tools like Prometheus or Datadog, enabling teams to gain insights into infrastructure metrics and detect potential issues. This data-driven approach facilitates continuous improvement and proactive infrastructure management. Conclusion. Terraform has revolutionized infrastructure provisioning by enabling infrastructure as code. With its declarative language, provider plugins, and modular design, Terraform provides an efficient and scalable way to define, provision, and manage cloud resources. By embracing Terraform and infrastructure as code, organizations can achieve consistency, reproducibility, and agility in infrastructure management, ultimately streamlining operations and accelerating the deployment of modern cloud-based applications.